In this project, we're going to explain you how we apply the control charts into an example of the real life. Our team is conformed by Gabriel Jimenez and Alejandra Mejia.
In this project, we are going to analyze the printing process of the copy-fast press. We are interested in knowing if the printing process is in statistical control to offer the customer a quality product. Therefore, with the help of control charts, we will analyze the current process that the company follows and, in case of finding faults, recommend immediate solution alternatives. Analyze the copy-fast production process to determine if it's under statistical control based on the number of defects per run of printer A.
The prints made on the studio machine are complex since the ink must be adequate to achieve the design that the client requests. This requires a lot of work since they achieve the objective. Up to 7 inks are mixed for inline printing, which means that the press must control several variables that cause failures. For this reason, after printing 400 meters, the printer must be stopped to inspect the print quality. If there are failures, the company must invest money and time, which means a lot of profits since they would require an improvement in the production line. For this reason, it is important to analyze the process and determine if the production line is under statistical control. The control charts were created by Sheward during the development of statistical quality control. Graphics are widely applied in the control of the industrial processes. However, there are different types of control charts for mean, ranges, proportions, and attributes. But for this project, the control chart that we will execute for the number of nonconformities without a given standard value is the Control C chart. The Control C chart is a tool that allows us to analyze the variability of the number of defects per group.
These are the data and the results obtained. These are the samples. Using the Minitab software and entering the data, we follow the sequence: stat, control charts, attributed charts, C, and in variable we select defects, and finally OK. This is the resulting control chart.
Now we can see that there are 8 points that exceed the upper control limit and there are points that constantly touch the lower control limits. As they are defects, it's not relevant that they are on the edge of the lower limit, since this indicates a good behavior, since there are no defects and represents a good characteristic in terms of the quality that press offers. Now, as for those that exceed the upper limit, it's necessary that the entire process be analyzed immediately to determine the causes that cause this point that drastically get out of control. Once the control chart is applied, it is enough just to see the problem. We must understand it to give feasible solution. Therefore, the printing press must rely on the statistical tools to understand the reason that causes this problem. A cause-effect diagram could be adequate to identify the causes that generate the problem, which can be due to factors such as the environment, material, technique, printer, operator, or the measurement, to name a few examples.
Once the data analysis has been developed, it can be concluded that the printing press has flaws in its process, which causes some products to be defective. Therefore, it means lost sales and capital investment in failures to improve the process. Consequently, it's necessary to solve as soon as possible the area where the problems are being generated, where this can be determined by the help of other statistical tools, such as the Ishikawa diagram. These tools allow you to brainstorm the factors that may be influencing the propagation of faults. In this way, the printing process can be improved and a better product can be offered to the Copyfast Printing Center customer. Finally, with the data obtained, we achieve our objective: to correctly apply the statistical tool control graph to analyze the data of a company and determine if its production process had failures. In this way, it begins to locate the points of improvement to increase this efficiency.